Hello friends, today we're going to discuss about linked list, especially singly linked list. And linked list we can categorize like singly linked list, double linked list, and then circularly linked list. So this video is very brief on the linked list, and that means singly linked list. So let's discuss how is differ from array or array list. So array has some drawbacks to dynamically allocating memory or expanding the memory. So to overcome this scenario, we can create a dynamic dynamic array list, and the dynamic array list also works like while if we add a new data, for example, this is the array, and here for example here 4 and then 3 and there again 4 and 7. So this is like a 0 and 1 2 3. So if we like to add in between here any data, then it's take longer time and then re-indexing. For example, if we delete it, then this one will be 1 and this one 2, and if we add any value here, then we have to re-indexing these things, this array, then it's take longer time. So in that case we can use linked list. And let's see. So linked list, while we create a linked list like a node, this is one node. So then this node is connected with this node, and these things happened by a node has two member. One is data and another is node itself, which refer to the another node. Okay. So if we want to like delete this one, the first one, then we could say b, this node is a head, so head position is this node. Okay, and we can gonna show the practical stuff. So in that case we're gonna see this nested class. Here we make a singly linked list demo class, and here we see this is node is a, and it's a very conventional way like while we work with linked lists. So we create a class called node, and any data type is could works here. T you could write e, and then I told you like a node has two element. One is data, this one we can say data or element, and another is reference for next node. So see here two element for this node class. One is node itself and another is element for data, and this is the constructor. So while we create a node, we need a reference node, means next node, and the data part, or we could say here element. And here is some getter and one setter to getter for node getter, like if we like to get the next node is null, or if it is not empty, we can find the value and also set the next reference. Now we create head and tail. So the first one will be head and the tail is last one, and also a size to counting how many nodes we have. And here we create a constructor for this single linked list demo, this class, and here size, integer size returned, so whatever the size it will be returned. And then is empty method, if size is equal to 0, then it will be returned true, means is yes, it is empty. Now we're going to create add method, and here the add first. So here we declared the head variable and this uh, head. So if we want to add something as an element, so here, as we know, like while we create a new node or add first, while we're gonna add anything, add a node in the first, then it will be head. So if it is empty, then tail equal to head, and then the size plus plus means the size will be increased. And as we're gonna add first, so we're gonna add it head, we're gonna initialize or referencing to the head. Okay, now if we want to add in last, then we need to create this one, and then we create a new node, and we gonna, so this is the way to create a node by given value, and as we're gonna add it at last, that means in tail, so there is the node will not reference and the next node, so that's why it's null, so there is no node. Okay, so but if while we're gonna add it, if it is empty, then head equal to newest, else tail dot set next means whatever is maybe, and the node has, or the single linked list has 5 elements, then the last element is tail, so tail and set next is newest. Okay, very simple. Now we see how to display a node or the linked list. So this is the statement, and then we declared a variable called current, and as we're going to start it from head, so we initialize it by head. So head is a node. So while current equal to not null, so like tail is null value. So when it get tail, then the loop is terminated. Now here, system.out.println and current.get element. So as we know, like get element here, so it's return the data, right? So here, whatever the maybe it's object or maybe it's integer or string, it will be written here and it will be printed. And then current, so this node will be referred as a next, and this that's way is continuous. Again, it's not null, so again it will be printed, right? So let's test our singleton. So here we create singleton instance here, and then we add last this one and add first this one. So while its output printed, then it will be studies this one. Okay, so let's run. Yes, studies this one. Now let's add something, and this one, and what it says like add first, so add first method will be add at the beginning, the add head of the single linked list. So Anupom is supposed to show Anupom studies this one and this one. Okay, so let's check, run it. We need to save it. So see, the first one is already and the second one like Anupam studies this one and this one. Great. Thank you. That's all for today, and see you in next video.